Creating a digital human, for us, is really understanding ourselves.
I'm Siren, and I'm a digital human.
Understanding how we look, how we move, and in the future, hopefully, how we think. Imagining all kinds of applications of this technology is just overwhelming. Collecting data was part of our DNA from day one. Limitations in the first days were everywhere. The size of my disk drive back then, I think it was 1.3 gigabytes, and now we're capturing 70 gigabytes a second. It just takes so much data in order to build a model that is robust enough to do something meaningful. We have hardware which can acquire huge amounts of data. Then we have software which can analyze this data. And the third set of technologies can synthesize new data, comparing the synthetic back to reality. So it's always about more data, but also about the way to understand that data. We know that the density of the data will increase, but compute power and data will probably only spike. We're definitely considering cloud to scale up to cover those spikes. We made this informed decision to switch to NetApp. Data Fabric is definitely our gateway to the cloud. That's how we switch from local into much more global compute. We're hoping that we are going to develop a framework where people, whether that's in medical or biometrics or entertainment or research, will each in their own field be able to use that framework and create something amazing. I'm Vladimir Mastilovic, and I'm data-driven.
We tend to label ourselves as a media organization, but at its heart, Dow Jones is a data company. We used to have data in silos, but to understand what our customers are looking for, we've had to unify those different data points. To do that, Dow Jones has had to create and utilize Data Fabric. We're able to access data when and where we need it. We spend less time worrying about how data's stored or where it's stored, and much more time focused on building the right experiences for our customers. One of our challenges was we need to be able to store more and more data in order to be able to progress as an organization. The cloud came along at a fantastic moment. Which technology do you pick? NetApp allows us to experiment with different technologies because we can easily move our data back and forth. That kind of flexibility is a game changer when you're looking to build and move really, really quickly in an environment that's changing really quickly. We still have on-premise, hosted data centers, and we use some of the big cloud providers, and being able to move data from on-premise to cloud to a hosted data center is integral to the future of our business. NetApp has worked with us to evolve their product suite to meet our changing demands with solutions that help us take advantage of the latest technologies. That's really helped us continue to stay at the bleeding edge The future of Dow Jones as a data business is that we provide the data that our customers need to make their decisions at a moment that they need it, in the right context and in the right experience. I'm Ramin Beheshti. I am the Chief Product and Technology Officer at Dow Jones.
There's a Yeti on my roof.
DreamWorks Animation is the home to the best filmmakers, storytellers, and artists in the world. We consider our artists our most valuable resource. Everything we do in engineering and every creative decision includes the artist at the core.
Technology should enable our artists to create art. And the best technology solutions are ones that the artists don't have to think about.
Our data fabric is a collection of systems, tools, and workflow to provide data services for animation, film, and television content creation.
Is that your home? No way.
Abominable is interesting. It has some of the more complex things to try to render and put on screen.
The Yeti in particular is quite complex. It has 2.7 million strands of hair with over 4,000 control points that make up the body and face. One single frame can contain millions of assets.
Our data fabric provides our artists with seamless data management at the best speeds with the lowest latencies to do their work. When building our data fabric, we use NetApp's tools to discover and better understand what's in our environment. To integrate data fabric into our environment, we added support into our cloud control plane, our analytics, and our automation platforms to better take advantage of what data fabric has to offer. Protecting our data fabric is one of the most important steps because we're dealing with content that was originally created by artists and it's irreplaceable. Our infrastructure and services are always evolving to keep up with the creative demand. As we resolve an issue or provide a capability, the artist will find a way to use it to make ever more compelling content. We're working with NetApp to future-proof, including the public cloud, to do data affinity to make sure the right data is in front of the right artist at the right time.
It allows them to put their imagination on screen without any limitations.
You can do magic? This is amazing!
Good morning, good afternoon, or good evening, wherever you are in the world. Today marks a significant milestone for NetApp. when we launch NetApp Project Astra, or Astra, like we would pronounce it in Iceland. I'm Sofía Theodóra Tryggvadóttir, and I lead the cloud marketing team at NetApp, and I'm going to be your host today. But first, I want to thank you all for joining us today in the midst of these unprecedented times, and I really hope you're all safe and well. But now it's my pleasure to introduce Jónsi Stefánsson. He is our CTO of NetApp Cloud Data Services business.
Well, this is the first virtual launch I think we've ever done before, and not exactly how I pictured that I would be announcing something that I've been dreaming about since joining NetApp, and that is Project Astra. But the world is always changing, and maybe especially in our tech industry. This epidemic has really shown us that we need to become more understanding, more flexible, faster to react, and provide scalability that we might have never done before. And scalability across on-premise and public clouds, and really bridging the gap between the public clouds and on-premise. We've been extremely lucky working with all these public cloud providers, and NetApp is in such a unique position where we are the only storage provider that is a first-party service on all of them. On the engineering level, it started off with us introducing Cloud Volume Services and Azure NetApp Files in all three of the big public clouds. That engineering collaboration and relationship is always getting better, closer, and deeper. Even though it started off servicing legacy VM-based workloads, it quickly escalated in servicing microservices and their native Kubernetes offerings as persistent storage. Being able to take advantage of those data management capabilities within Kubernetes is something that nobody else is delivering. Our service delivery engine that runs all of our public cloud services has been developed on top of Kubernetes and is running and managed within the native Kubernetes offerings of all these public clouds. We always wanted to close the loop by having all the storage capabilities of NetApp natively available within Kubernetes and the data management capabilities. Therefore, providing that the same flexibility, the same portability to stateful applications and data like Kubernetes has done with stateless applications.
Today, cloud-first organizations are adopting Kubernetes as the de facto standard to improve development agility and accelerate their move to the cloud. But this shift introduces new challenges. Many cloud applications require persistent storage, but lack the intelligent data services that provide seamless integration with Kubernetes. These containerized apps are complex and difficult to back up, recover, or replicate. Also, the variety of Kubernetes flavors creates vendor lock-in. Up until now, application teams faced a difficult choice: rely on the limited solutions from cloud providers or work with unproven startups. Well, say hello to Project Astra from NetApp. Astra unlocks the power of Kubernetes, making it fast and easy to discover applications, clusters, and data across on-premises and cloud environments. It allows you to rapidly back up and restore fully configured application clusters and their data. In a single command, you can clone an application with all of its objects and data, then migrate it to a different cloud, all while the original app is still running. Better yet, Astra works with any Kubernetes flavor in any cloud and on virtual machines. Only NetApp has the knowledge, the expertise, and a track record in both enterprise storage and Kubernetes to deliver the right solution. See how Astra is changing the game with storage built from Kubernetes for Kubernetes. From NetApp.
I hope that video has you excited to learn more about Project Astra. So let me introduce to you Eric Hahn. He is our VP of Cloud Data Services Product Management.
Thank you. I'm here in my home in California, virtually connected with you. I wish everyone safety and the best possible in times like this. As our team thought about the current climate and the technology we are working on, it's important that we lean forward in times like these to see what innovation can provide. Looking back, it's been an amazing experience to be part of the original Kubernetes team and to see where Kubernetes has gone as a community-driven project. Traveling the world and working with DevOps teams, we see the importance of automation, Kubernetes, and microservices as a way to digitally transform companies. And that trend will only continue. And it's also in times like these that we think about where we are in the technology adoption curve. And we start to think about what is truly possible. And we have the opportunity right now to change how all applications and services run. And we want to take that step together. I'm reminded of a recent CNCF stat that talks about 78% of users are running Kubernetes in production. That's an amazing number. We should all be proud of that. That's a great outcome from a project that only started 5-6 years ago. But only 14% of the same respondents are using storage in production, and that's a drastic gap. And for those teams that are reluctant to run data-rich applications in production in Kubernetes, we get it. There's a lot to consider, and there's fundamental gaps that need to be addressed. As a community, we have an opportunity to change the practice and belief of what is truly possible in Kubernetes. Now, it's easy to talk about components and pieces, but it's probably more important to talk about the end-to-end experience and vision of where we can head together. Astra is a service-based experience for how to run data-rich applications in Kubernetes. Rather than take pieces of a solution or a siloed approach, Project Astra illustrates the fundamental principles that we think are necessary for data-rich applications. The promise is simple. All applications should run in Kubernetes, and all applications should be portable. This includes those mission-critical data-rich applications and those that bring about the next set of innovation and experiences. Project Astra will focus on delivering 3 key experiences to further that discussion. 1, run with the Kubernetes and infrastructure of your choice. Use the best cloud for your workloads, use the best of on-prem, and use the best tools without artificial constraints. 2, application and data management should be unified. We shouldn't think about it as pieces of compute, pieces of storage. Rather, we should be able to think about the end-to-end delivery of application and data and what that means for IT teams. And 3, let's keep applications, let's keep Kubernetes, let's keep all our workloads portable. The promise of portability is one of the fundamental pieces of Kubernetes, and that should continue. We want to model this mindset and work with the community to bring about this change. And so to illustrate further, let's take a deeper look at Project Astra.
This demonstration introduces Project Astra workflows, as well as an overview of common deployment models and use cases. Project Astra by NetApp is a cloud-native solution focused on application data lifecycle management in the Kubernetes environment. The primary goal of Astra is to simplify the consumption of storage while managing the end-to-end data lifecycle for stateful workloads. Astra itself is Kubernetes native and is offered as a cloud service. Astra provides key data services that are critical to the operation of popular enterprise applications. These include SQL and NoSQL databases, messaging, search and indexing, AI/ML analytics, and dev test CI/CD pipelines. Astra understands the application construct in containers and delivers services through the custom resource framework, which is widely used by the ecosystem to extend Kubernetes functionalities. A key differentiator in Astra is its ability to not only fulfill application data management in major public clouds, such as Microsoft Azure, Google Cloud, and AWS, it also offers the same service level for on-premises enterprise data centers with NetApp Data Fabric. NetApp's Data Fabric is an architecture and a set of data services that provide consistent capabilities across a choice of endpoints spanning on-premises and multi-cloud. Amongst many layers of data services, Astra offers a control plane for applications data management, and when combined with NetApp's Data Fabric, it offers complete control over full-stack application backup and restore, as well as clones wherever they reside in the fabric. Let's have a look In this scenario, the Kubernetes administrator registers their cluster that is running in a public cloud with Astra. The first step in the registration of the cluster in the public cloud is to register a service administrator account with permissions to perform operations on behalf of the user account. Then, the Kubernetes administrator registers the cluster authorization tokens that are required to access the cluster. Astra completes the registration by installing operators in the public cloud cluster. As for on-premises use cases, it is the Kubernetes administrator who registers their cluster with Astra. Lastly, as observed in the management console, the user sees 2 Kubernetes clusters registered to Astra. Let's have a look at how Kubernetes applications are discovered and registered in Astra. This is particularly important for customers with existing deployments. Not all applications that are discovered must be registered with Astra, and customers have complete control over which workloads should benefit from Astra. The user must initiate the discovery, and in a matter of seconds, Astra offers a complete list of applications running in those clusters. The Astra user decides which apps are registered for advanced data services. Additionally, Astra discovers the namespaces where those applications are running. It queries the Kubernetes API server to identify pods, config maps, secrets, and other objects associated with that namespace. Upon completion, Astra displays the namespace it has discovered in that cluster. By default, the application discovered in those namespaces are not registered. The user or administrator must explicitly decide to change its state to registered before Astra data services can take effect. Once registered, Astra will provide select services for those applications in that cluster. The user can either use a Helm chart or the command kubectl apply -f to launch the application. Astra serves the persistent volume claims of registered applications by binding them to industry's best-in-class data services offered by Azure NetApp Files, Cloud Volume Services for Google Cloud, as well as Cloud Volume Services for AWS. Similarly, for on-premises clusters that are registered to Astra, the persistent volume claims are mapped to NetApp's Data Fabric services. As observed in the management console, the user sees 2 Kubernetes applications registered to Astra. This brief demo will illustrate a key capability in Astra, which is full-stack application portability, including application state and associated persistent storage. In this scenario, the administrator would like to move an application from one namespace to another in the same cluster. There are several scenarios that apply here, but this use case represents a backup and restore operation which consists of the entire application stack, not simply the volumes associated with those pods. Here's the basic workflow to back up and restore an application in the same cluster in a new namespace. The user selects an application to back up. Astra quiesces the application stack and captures application-consistent snapshots for the data volumes. Additionally, all configuration data, including config maps, pod specs, secrets, as well as other objects, are also captured, which are required to wholly restore the app in the target namespace. Then, Astra backs up the snapshots to a target, which could be native object storage services provided by the cloud service provider. Astra then creates a new namespace in the target cluster. Then, Astra fetches the configuration and snapshot data from object storage service to restore. After successfully restoring the app in the new namespace, Astra will continue to provide data management for this application as long as it remains a registered app. By design, Astra abstracts all complex tasks. From the user's perspective, this will appear as a single command or a click of a mouse. With Astra, customers can schedule application-consistent snapshots to improve RPO and RTO times. The portability and application consistency aspects of Astra offer a slew of advantages. They include restoring applications to a different Kubernetes cluster in the same or perhaps a new public cloud, or the entire cluster may be restored in the same as well as a new public cloud. And finally, it doesn't stop here. NetApp will continue to innovate and help our customers do more in Kubernetes with Astra. Simply said, Astra is an essential part of the Kubernetes application data management framework. With Astra, our customers can make application data as portable as the applications themselves are in Kubernetes. We welcome the opportunity to have you join the upcoming Astra private preview, and for more information, please visit cloud.netapp.com/project-astra.
Now, the question many of you may be wondering is, why is NetApp the one doing this, and why now? So to answer that question, or questions, let's hear from Jeff Prem. Jeff is our VP of Engineering for Project Astra, leading our development efforts. Additionally, Jeff leads NetApp's ONTAP engineering, specifically related to our cloud products. So over to you.
Now, as Eric explained, Kubernetes is an amazing platform for developing and deploying cloud-native applications in multiple environments, in the public cloud, in enterprise data centers, and even at the IoT edge. However, Kubernetes doesn't really inherently solve any of the data management challenges that are associated with deploying stateful applications in production and at scale. And in hybrid and multi-cloud environments, Kubernetes goes a long way to solving application portability problems, but it doesn't really do anything to solve data mobility or data portability problems. We already have the world's #1 storage operating system with ONTAP, and there's always been a comprehensive focus on data management capabilities, and it's a differentiator for ONTAP. We've innovated over the course of decades, literally, and built and perfected data management capabilities. Now we're taking all of that experience and all of that focus and bringing it to Kubernetes with Project Astra to give that same application-level data management experience for cloud-native applications. And NetApp is no stranger to either open-source projects or cloud-native deployments. We've sponsored and contributed to some of the world's largest open-source projects over the years. We're platinum members of the CNCF and major contributors to Kubernetes storage and the container storage interface. We're also the creator and maintainer of Trident, the world's first operator-like storage orchestration layer for Kubernetes. And Trident is already providing persistence for tens of thousands of applications today. We've also built and now operate a cloud-native data management service in partnership with the world's largest public clouds. And we're going to take advantage of that cloud footprint to provide a managed, service-oriented experience for Project Astra in the cloud. That's it for me. Thank you for the time, and I hope to hear more of your feedback as you get to take a closer look at Astra and experience it for yourselves.
I hope you're all as excited as we are about Project Astra, and I encourage you to go to NetApp Cloud Central and sign up to learn more and get the updates as we develop and release Project Astra. Thank you all for joining us today.